In this section, I'm going to talk about an introduction to the immune system. The immune system is really just a compilation of various cells and chemicals that work together to perform a common function. The functions of the immune system include to protect the body against foreign organisms or objects that happen to enter into the body. And it also prevents the growth of abnormal cells, which could be cancer cells or virally infected cells, so that those cells aren't allowed to proliferate or grow and expand in the body. Your immune system, like I said, is just a bunch of cells and chemicals. And those cells and chemicals have to have a way to be able to identify the cells that belong in your body and the cells that don't belong in your body. And the way that they do this is by looking or evaluating the different antigens that are on the surface of these cells. Antigens are going to be cell surface identification markers. So another way to kind of describe antigens that I like is they're kind of the cell's ID card. If you want to go on a trip in an airplane somewhere, you're going to have to present your plane ticket or your boarding pass and your driver's license or some type of form of identification. If a cell wants to remain in your body, it's going to have to present a certain type of antigen. And if that self antigen isn't present, your immune system is going to become alerted and going to want to attack that cell. So I just kind of made reference to self versus non-self. So self belongs in the body. Non-self does not belong in the body. So self is your own tissues, your own cells, your own antigens. Non-self are going to be foreign antigens. And your immune system cells will bump into the antigens on the surface of other cells to determine whether those are okay to stay in the body or whether they have to be eliminated. There are different types of immunity. We have innate, which are non-specific forms of immunity, and acquired, which are specific forms of immunity. Innate consists of the first line of defense and the second line of defense, while acquired, also known as adaptive immunity, consists of the third line of defense. So I'm going to give an analogy to the immune system and the first, second, and third lines of defense. But first I'm going to give brief definitions to these. So the first line of defense is surface protection that tries to prevent pathogens from getting into the body. So it tries to prevent an infection from happening. The second line of defense is the pathogen got into the body. It started to overgrow. It's starting to cause an infection. So you have these cellular and chemical responses that are not specific, and they help protect the body or prevent further expansion of that infection. The third line of defense is the strongest form of immune defense. And in the third line of defense, we have B cells and T cells that specifically recognize the pathogen that's causing the problem, and they will target and eliminate only that pathogen. It's a very strong, overwhelming response, and sometimes miscommunications in those responses can lead to some devastating long-term effects on the body. So let's talk about these in reference to the scenario. So let's say you're outside at your family's house and it's winter and you just built this huge, wonderful snow fort, and the neighbors next door are throwing snowballs at you. And you don't want to have a snowball fight with them. You want to just fight with your family and have fun and do your own thing. So your neighbors are just constantly throwing snowballs. They want to start a fight. So you're talking to them, you're saying, hey, don't do this. You build up your walls taller on your little snow fort to try to protect yourself. That's kind of like the first line of defense. So first line of defense, these are things that are going to prevent a fight from happening. Whether you talk down the neighbors or whether you have built up the walls stronger on your snow fort, you're trying to prevent a snowball fight between these neighbors. So in the body, we have some pretty basic features that will prevent infection from coming in. First of all, physical barriers like the skin. The skin is a physical barrier that bacteria and most other microorganisms can't penetrate. We have chemical barriers. Chemical barriers include saliva. There's salivary enzymes that can help degrade pathogens that are coming into the mouth. We have the secretions on the skin. So the skin has a low pH or an acidic pH, and it has a high salt concentration. And most microorganisms don't like growing in that hostile environment. Have you ever seen a moldy person? Probably not, because molds don't like to grow in the presence of low pH or the high salt concentration. And then there's genetic components. So genetic components have to do with missing certain receptors that a virus, for example, would need in order to be able to infect a person. So the first line of defense, that's just basic protection that we have. It includes the skin, our tears, our earwax, all of the secretions in our digestive tract that help prevent infection, anything on the surface or that lines body cavities that would try to prevent infection. So back to the snowball scenario. Now, these people threw a snowball, one of them hit your face, and you're like, okay, it's on. So you're in a full-blown snowball fight now. And there's a lot of people running around. You don't know who initially started the snowball fight. So you're throwing snowballs at every person that you meet. You're hitting everybody with these snowballs. That's kind of like the second line of defense. The second line of defense is nonspecific in that it doesn't actually recognize what the underlying problem was. It just produces this overwhelming response to try to clear the infection from the body. This is where we can have a lot of chronic infections happen. So, for example, in the case of Borrelia burgdorferi or Lyme's disease, you get Lyme disease, the bacterium gets into your skin, and sometimes after the bacterium goes away completely and there's no sign or any antigens or anything of the bacterium present in the body, the immune response is all out of whack and it keeps producing this inflammatory response, and it's the immune response's overreaction to the dead pathogen that's been gone and wiped clear from the body that keeps this kind of chronic symptoms going. So you can't really treat something like that with antibiotics because the microorganism is gone. The microorganism came into your body, messed up your immune system, caused this severe overreaction, and now it's really a matter of controlling the immune system and slowing down the immune system after the fact. And that's not just the case with Lyme disease. There's a lot of other pathogens that happens with. Malaria is an example of where the Plasmodium parasite gets into the body and it causes this upset between the immune system. And the immune system gets regulated by all of these chemicals, these cytokines, and some of these pro-inflammatory cytokines keep that immune system stimulated and cause overwhelming immune responses when it's really not that necessary. So our second line of defense is nonspecific. So like I said, you're throwing snowballs at everyone. You're not even paying attention to where they're going or who you're hitting. The second line of defense that has the inflammatory response. Interferons. Interferons are chemicals that are going to predominantly protect you against viral infections. Phagocytosis, so eating bacteria that come into the body. So you have phagocytic cells that are going to consume the pathogens that have come into the body. And complement. The complement system kind of mediates phagocytosis. It serves as a receptor for binding to phagocytic cells and helps a component of the complement system aids in phagocytosis. It helps aid in the inflammatory response, and it also helps to form this membrane attack complex and help puncture holes inside of bacterial cells. So complement is a series of a bunch of different proteins that can modulate the immune system and your immune responses. I will be talking about the inflammatory response in more detail in just a little bit, but those are the basic components of the second line of defense. You also have some cells here. So we have natural killer cells. Sometimes abbreviated NK cells. These cells are going to kill any cell that looks abnormal. So if the cell doesn't look right, it's going to be eliminated. Natural killer cells are known to destroy cancer cells and virally infected cells, any cell that looks abnormal. You also have fever. When you increase your body temperature in response to a pathogen. Increased body temperature causes the denaturation or unfolding of proteins. So if proteins get unfolded in a bacterial cell, the enzymes, which are predominantly made up of protein, will also be unfolded. And when enzymes are unfolded, they are not functional. So it basically shuts off all the metabolic capabilities of the cell, and the cell eventually dies from that. So fever is definitely a good thing up to a point. After a certain point, it starts to cause our own protein destruction and our own enzymatic failure, and then we can get sick and we can die or slip into a coma and die after having too high of a fever for too long. But short-term fever, low-grade fever is beneficial in clearing pathogens because it destroys their proteins. So this snowball fight is getting out of hand. You've been throwing snowballs at everyone. You're starting to run out of snow. You feel overwhelmed, so you go back to the house and you call for your cousins. Now your cousins come out and they're like, what's the problem? And you sit down and you explain, this person started this snowball fight with us. It's just the neighbor people. And now your cousins have been activated to only throw snowballs at your neighbors. So you're no longer going to just be throwing snowballs all over the place. You are going to specifically target the ones that cause the initial issue. And you're going to be only throwing snowballs at the source of the problem. That's kind of like your adaptive immune response or your third line of defense. In the third line of defense, you have B cells and T cells that have specific receptors. A B cell is going to have an antibody on the surface, and a T cell has a T cell receptor on its surface. And these B cells and T cells have specific receptors that will recognize the specific antigen on the surface of the pathogen that's causing the problem. So just like you were outside before in your second line of defense, you're throwing snowballs at everything. When you call your cousins, they're like, no, we're not going to throw snowballs at everybody. Who actually caused the problem? Now we're going to target it, and we are going to end this snowball fight. So the cousins, like the B cells and the T cells, are going to specifically recognize the pathogen that caused the issue and only attack that pathogen. And the thing about this is when you do call your cousins can get on the phone and call their cousins and their friends, and they can call their friends. And before you know it, you have this large association of people that can join in on this snowball fight. And they're not just going to attack the neighbors that initially caused the fight. They're also going to attack anybody associated with those neighbors. So anyone in the entire city of wherever you live, they're going to try to specifically attack the people who are starting these snowball fights. So in the body, if there's a pathogen and you have an infection, let's say it's a paper cut, and that infection started to get really nasty, a really bad bacterium got in there, it's not clearing up with your second line of defense, and you need to call your third line of defense in as backup. If the third line of defense is activated, it will cause a multiplication of T cells and B cells in the body. And those T cells and B cells will circulate through your bloodstream and go everywhere in the body that they could potentially have the pathogen. And they're going to clear that pathogen from the entire body. So they're no longer just going to stay at the source. They're going to survey the entire body, go everywhere in the body, and produce this massive attack against that specific pathogen. Not against every pathogen, against the pathogen that stimulated the problem in the first place. So you can read through the definitions here a little bit more. We will be talking about active, natural, passive, natural, artificial, active, and artificial passive when we get to the adaptive immune system section. But this is just an overview of the main components of the immune system. So now I'm going to talk a little bit about the inflammatory response. And the inflammatory response is a response to tissue damage. If you roll your ankle, it will get inflamed. You'll see the redness, the heat, the swelling, the pain. Tissues have been torn, it's damaged. But is there bacteria in there? Not necessarily. If the skin wasn't punctured, there's no bacteria getting in there. It's all enclosed internally, there's no bacteria there. So you don't necessarily need bacteria in order to stimulate the inflammatory response. A lot of different microorganisms can stimulate inflammation, but also just something as simple as tissue damage can stimulate inflammation. So you really begin with damage of tissue. When tissue is damaged, and in the example that they give in this picture, you have a wound. Bacteria are going to enter into the wound, and if there are no bacteria, the tissue damage itself, the ruptured cells, will cause a change in the amount of potassium surrounding the cells, which can elicit the immune cells to notice that there's tissue damage going on. If you remember from previous classes, potassium is intracellular cation, and it's in high concentrations inside of the cell. So if you have tissue damage, you're going to start bursting open those cells, which is going to release a lot of potassium to the outside environment, and cells can be sensitive to that change. So the first thing that's going to happen is you're going to have mast cells that sense this damage. Now, platelets could come to the area and they could start repairing any, broken blood vessels and such. But when these mast cells determine that there is tissue damage, they're going to release chemicals, and those chemicals are going to cause vasodilation and vascular constriction. So what's going to happen is the mast cells produce these chemicals, and that's going to cause the vasodilation. When you dilate your blood vessels, they're getting bigger, which is going to bring more blood to the area. And blood is hotter than room temperature most of the time, so we have a hotter bloodstream than would be felt on the outside of the body. So that's going to cause the skin to feel warm. So vasodilation is going to call more blood to the area, which is going to cause redness, and heat. Those chemicals are also going to increase the permeability of the blood vessels. So that those blood vessels become leaky. And when they become leaky, fluid is going to start leaking out of the bloodstream, and that's going to cause swelling, which leads to pain. Whenever there's swelling, it's accompanied by pain. Those chemicals are also going to stimulate neutrophils to come to the area. Neutrophils are going to squeeze through your blood vessel walls, and they're going to start migrating toward the source of the chemical release or the presence of bacteria. So through chemotaxis, they're going to migrate through the tissue to the source of the damage. Neutrophils are going to clear debris. So if there aren't bacteria or pathogens entering, they're still going to be there cleaning up the debris, or they're going to help clear the pathogens from the area. So they're phagocytic cells that are going to help clear all of the damage away. And then later on, you're going to have macrophages that are also going to be clearing some debris, and they're going to secrete cytokines that kind of promote or moderate this inflammatory response. Like I said before, the inflammatory response happens due to tissue damage with or without pathogens present. And you should make note of the 4 cardinal signs of inflammation: redness, heat, swelling, pain. So the 4 cardinal signs of inflammation: redness, heat, swelling, and pain.